In question 29, we're told the following. In topology, a point with at least one path leading from it is called a node. Any path joining two nodes is called an arc, and an area surrounded by arcs is called a region. Even the area outside a shape counts as a region. And we're supposed to complete this table here. Let's look at number 1 because it's done for us. Okay. Clearly we have 4 nodes. That's easy enough to see. Let's be careful about the arcs. 1, 2, 3, 4, 5, 6. So that's done for us as well. And the number of regions, why are there 4? Because 1, 2, 3, and the outside region counts as the 4th region. Let's do one of our own, number 2. Clearly there are 6 nodes, and clearly there are 12 arcs. Looking at the regions, there are 6 in between the arcs like so, 1 inside and 1 outside. That makes 8. Number 3 is interesting. There is only one long arc connecting 2 nodes. We have 2 and 1. And the region, well, there is only one region because there is no outside and inside to this pattern. The arc does not form a closed loop. And so we only have one region, and it is this snaking region here. It is both outside and inside, so to speak. So there's only one. Looking at the last pattern, we have clearly 1, 2, 3, 4, 5, 6, 7 nodes. The arcs are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's always good to mark drawings if you're trying to count something on it, okay? And regions, there are clearly 5 of them. Okay. Now, the meat of this question consists in this formula we have to find connecting N, R, and A. Now, for those in the know, this is actually something called Euler's formula, named after an extremely prolific mathematician, Leonhard Euler. But we are not expected to know about Euler or his formula. We're supposed to figure this pattern out just from the evidence of this table. And what I would suggest here is the same sort of reasoning one would use for sequences, right? If one is given a sequence like 1, 4, 9, 16, now clearly these are the square numbers, but if we didn't know that, we're a beginner sequence pattern finder, we might try something like, well, maybe it's plus 3, right? Because from 1 to 4 it's plus 3. But that fails on the second increment because now it's plus 5. And so maybe what we do is we add 2 every time to the difference between the numbers. And that seems to work because the next one is plus 7. And so this way we can come up with an initial guess and then adjust it, and that gives us the correct pattern. Similarly here, I think the first thing one would try is probably, well, maybe it's adding N plus R and we get the third one. But it doesn't quite work because 4 plus 4 is 8 and 6 is 2 less than 8. But maybe it's just that. Maybe you add N plus R and then you subtract 2 and that gives you A. Let's test that. 6 plus 8 is 14, minus 2 is 12, 2 plus 1 is 3, minus 2 is 1, 7 plus 5 is 12, minus 2 is 10. So it does actually work. Right? So it's a sort of scary looking question, but it's solved pretty easily after a bit of adjustment. And so the formula, and this is in fact Euler's formula, is N plus R minus 2 equals A.